So for this problem, I hope you realize that this is just an upside down problem that has zeros at 0 and at 22, so that makes choice B. And then if we're using an LRAM, we're putting those rectangles, the left corner of the rectangles is what hits the graph. So hopefully that's familiar. And then to do the estimation, we want to divide that 22 up into 4 subintervals. So 22 divided by 4 is 5.5, so each one of these rectangles is 5.5 wide. But then how do we figure out how high the rectangles are? Well, for the first one, x is 0, right? If we substitute in 0, we get 0. For the next one, I'm coming over and adding 5.5 to it, so what's f of 5.5? Well, I got a little lazy and used my calculator to calculate that. Then I'm going to add 5.5 again, and so I substituted in 11 into f of x, and I got 121. Then I substituted in another 5.5, additional 5.5, which is x is now 16.5, and you substitute that in, you get another 90.75, and you kind of see that in the parabola. And then that's our 4 subintervals. We'll do the products and add them up, and I got that for an answer. So for question 2, we're just going to do the antiderivative. Well, the antiderivative of 5 sine x, I brought the sign out. The antiderivative of sine x is negative cosine x, and then I multiply the 5 back through. And then I'm doing the f of b minus f of a. So if b is 2 pi, we're going to do negative 5 times the cosine of 2 pi. Well, the cosine of 2 pi is the same as the cosine of 0, so that's 1 times negative 5 is negative 5. Then minus, because it's f of b minus f of a, well, minus a minus turns to plus, and the cosine of pi is negative 1, and 5 times negative 1, and then you get negative 5 plus negative 5 is negative 10. Next one, we're going to find the average value of that function using the antiderivative. Well, remember the formula for the average value is 1 over b minus a times the integral from a to b of f of x dx, right? So I found 1 over b minus a, which is, so it's 1 over 2 minus negative 2 turns to plus 2, so that's where the 1 over 4 came from. And then I did that from negative 2 to 2 of that function. So then I found the antiderivative. I added 1 to the 3 to get 4, divided by 4 to get 1x to the 4th. Same thing with the 3x squared. That became 3, divided by 3. That first 3 cancels out. Then I distributed that 1/4 through just to simplify my work, and then I dropped in 2. 2 to the 4th is 16, divided by 4 is 4. 2 to the 3rd is 8, divided by 4 is 2. So that's the f of b minus the f of a, which is the exact same thing, except when I raise negative 2 to the 3rd power, I get negative 8. Negative 8 divided by 4 is negative 2. So then I'm going to get 6, and this is going to become 2, and minus 2, so 6 minus 2 is 4. So for question number 4, I noticed it looked complicated, so I said, well, can I simplify this? And I said, well, hey, I noticed that 1 over x plus 2 is the derivative of ln of x plus 2, so I decided to use a u substitution of u equals ln of x plus 2. I took the derivative of that, and that's exactly what we got going on here. So what it became was just 1 over the natural log times du, so the antiderivative of 1 over u, what I say natural log, it's 1 over u. The antiderivative of that is the natural log of the argument, so I just back substituted in. I see I made a mistake right here. I should have another ln right there, as you can see in the answers. Okay, and then of course the plus c. So for this one, I thought I'd do another u substitution because I noticed the secant squared is the derivative of tangent. So I didn't have to do a u substitution here, but I thought it'd be easier if I did. So I said u is tan 3x, the derivative of that is secant squared 3x times the derivative of 3x, which is 3. And And so then what did I do? Oh, I see. So I've got the 3 here, and the secant squared dx is all gets replaced with du. And the tan 3x is the u. And then I did, because I am doing a u substitution, I figured I'd change my limits on my integration. So I said, what's u of pi over 12? So I dropped in pi over 12 for the x. 3 over 1 times pi over 12 becomes pi over 4. The tangent of 45 degrees is 1. And then 7 pi over 12, well, that's in quadrant 2, and tangent's negative 1. So I'm integrating from negative 1 to 1 of u du. Makes it a much easier question. The antiderivative of u is 1/2 u squared. If I drop in 1, I get 1/2 minus, well, the square of the negative 1, the negative cancels out. So it's 1/2 minus 1/2 is 0. So for question 6, I saw it didn't look like a u substitution would work, so I decided to use integration by parts. So I said, if I remember about Lipit. So I don't have a log, I don't have an inverse trig function, I do have a polynomial, so I let that be u. And I said cosine x dx would be dv, and then I did the derivative of that, I integrated that, or found the antiderivative of that, and then the formula for integration by parts is u times v minus the integral of v du. So I went the product of those two minus the integral of sine x times dx. The antiderivative of sine x is negative cosine x, so a negative negative turns it positive, and then plus c, and then they told me I've got this initial value problem where when x equals 0, y equals 2, so every place I saw x I dropped in 0, and the y became 2, that gave me c equals 1, and lo and behold, that's what they had. What I'm hoping you remember about this problem is that the solution to these kind of differential equations is you're going to separate your variables, and then you can jump right to that answer. If you don't remember how to do that, see me and we can walk through it. Then they told me, so I got to find some things here. Well, first, I got to find out what k is. So when x equals 0, t equals 0, y equals 1, so I replaced everything there, and I got a equals 1, so that's nice. And then I got to find the constant k, so I just substituted in, no, I found k, so where am I? Oh, right here, sorry. When y equals 5, t equals 4, so that's why I wrote 5 equals e to the k times 4, and which means to get rid of get that 4k out of the exponent, I took the natural log of both sides, I divided by natural log of 5 by 4, and I got 0.402. So then for part C, they want me to evaluate it when t equals 8, so I went e raised to the 0.042 times 8. To get d, I went e to the 0.042 times 9, and then, or b, let's see, sorry, get that mixed up. B, we're going to use 7, and you can verify that those are indeed the answers. So for this function, this problem, I graphed y equals 3x, I graphed 3 over x squared, which is just the reciprocal function, and they want me to find this red area. So the issue with this is what functions above the line changes. So I figured out where those two things crossed, so I did that here. I said, where does 3x equals 3 over x squared? I multiplied by x squared, I divided by 3, got x cubed. The cube root of 1 is 1, so I know that point is 1. So I integrated for the 3x being the function from 0 to 1. So I found the antiderivative of that. I evaluated it from 0 to 1. Drop in 1, you just get 3/2 minus 0. So that's why I just stopped at the 3/2. Now I'm going to integrate from 1 to 5, which is my other bound here. And so the antiderivative of 3, so just in case you're wondering, I thought of this as 3 times x to the negative 2. I'm going to add 1. So that becomes 3 times x to the negative 1. Then I'm going to divide by the negative 1. and then I rewrote this as negative 3 over x. I'm going to evaluate that from 1 to 5. So I think I can drag this over. Yeah. So I got the, okay, so we're going to drop in 5. That's where I got the negative 3 over 5. Minus, I'm going to drop in the 1, which is negative 3, but it's f of b minus f of a, so that minus turns plus. I rewrote these so I had common denominators, and then I combined them. That's where I got the 12 over 5, plus I have to add in that area I had at the beginning. And you add those two answers, and that's what that area is. So for this question, we've got the graph. They're asking us where's the particle at the end of the trip. So that's at t equals 10. So one thing I noticed is that this area is positive, this area is negative, and they're equal. So they're going to cancel off. So then I just got to worry about the area of this triangle, or this trapezoid. So mathematically what I did is I'm finding the integral from 0 to 10 of f of t dt, and then the particle starts at x equals 3. So that's why this is going to be the net distance plus that initial 3. So to find that integral, I just did, as I said, those areas canceled off, so I'm just worried about the area of this trapezoid. So it's 4 high, so 1/2 times 4 high times 6 long is base 1 and 3 long is base 2. That's 9 times 2 is 18, plus the 3 that I started with gave me the 21. Then to get the total distance, all I have to add on to this is this negative area and that positive area. So basically all I have to do is find the area of one of those triangles. So 1/2 times 2 times, how tall is that, 4? And then I'm going to double it because there's 2 of them. So it's going to be, basically I'm going to add, so that's going to give me times 2 is going to give me an additional 8 units traveled. So if I've got the 18 that I traveled from here, from the trapezoid, plus that 8 there, that's where they're getting the 26 from. Notice I don't care about the 3 where I started at, because I'm just looking for distance traveled. So this problem starts to get to the easier questions, I thought. Here's the function that shows me the increase. Let's see, this function goes the increase the cost, so we want to find the total increases over those 4 years. I'm just going to do integrate from 0 to 4 of that function, and that's what you get when you f and int that. So for this problem, we have to remember how to graph cosecant. And so what I'm hoping you remember from pre-calc is that period of the cosecant's reciprocal of the sine graph. So I just sketched a sine graph, and then I put my vertical asymptotes in. And there's one over here also. And then you just come down and hit the graph, come up like that. So that black graph is the cosecant graph. And so we're looking for the region bounded by that graph, and the line y equals the square root of 2. Well, since this is 1, and we know the square root of 2 is slightly bigger than 1, this is the line y equals the square root of 2. So it's this area here that we're going to revolve around the x-axis. So what we have is I'm seeing a washer, so we're going to revolve this around the x-axis. So I'm seeing a washer situation. So what I'm seeing for the outside radius is, let's come down the x-axis. So the square root of 2 is the outside radius. So radius squared times pi. So that's going to be 2 pi. Minus the inside radius. Well, the inside radius is the cosecant graph. So minus cosecant squared times pi. And we're going to integrate that from the bounds. So we got to figure out where those two graphs intersect. So what we're going to do is we're going to say, where does cosecant x equals the square root of 2? Well, remember that it's cosecant's reciprocal of the sine. So we're really looking for where does the sine equal 1 over root 2, or root 2 over 2 if we rationalize. And I'm hoping you remember that this is a reference angle of pi over 4, 45 degrees, and there's 1 over here. So we're going to integrate this from pi over 4 to 3 pi over 4. And I think that's it. So we're going to separate that. We could do this with f and n. We probably are going to want to eventually use a calculator since you're telling us to round to the nearest 100th. But there's some things we can do here. Let's see, the antiderivative of 2 pi is 2 pi x. And then the antiderivative of negative cosecant squared times pi is going to be the same thing as pi times the cotangent of x. And we're going to evaluate both of these from pi over 3, pi over 4, sorry. Why did I write 3 here? It should be 4, pi over 4. So pi over 4 to, let me erase it, no. So we're going to evaluate this from pi over 4 to 3 pi over 4. And the same thing here, from pi over 4 to 3 pi over 4. We really could do this by hand. You know what? I'm just going to FN it the whole mess because I'm running out of room. It's getting to be a hard calculation. So let's just FN into it since that's acceptable here. So that's what I put in my calculator, y1. I also noticed that this should be squared. When I tried to calculate it, I didn't get the right answer. So, because that takes care of the cosecant squared. So then, when I FN into it, I got the right answer. So that's how you do it. So this one's fairly involved, and what I did instead of recording a video is I've done all my work out on paper and I scanned it. And the other thing I did is because the integrals are pretty nasty as far as evaluating them, I just FN'd into this. So what you're going to see in my answers are not exact values. They're going to be decimals. And when I go through your quiz, I'll make sure that you get the correct points for you if you just did the FNN. So what you got to remember about arc length is it's going to be 1 plus the derivative squared, and we take the square root of that times dx, and then the integral from whatever to whatever. So in order to find the expression that works that works for the arc length of this function or this relationship, you've got to take the derivative of that. So I wrote it as to the 1/2 power, and drawing the 1/2 down in front, take away 1, and then you're going to do the chain rule, and then that cleans up to this, and then it's the derivative squared. So this mess here cleans up to that, and then I square it, which would cancel out the negative squared. So choice D is the correct answer. And then because this is just a sideways parabola, if you want to think of it that way, or the part of a circle, right? And we're only integrating it from -1 to +1. Okay, so that checks there. That's how long that arc is. You can almost see the circle. The radius of 2, you can almost see that part of it. And then you just FN int that beast. And so right there is what we're going to, choice D, right? Yeah, we're going to just do FN int on that, and that should give you the answer.